So this is going to be the last material, actually, I think that we'll cover for this unit. This is going to be the last little thing to learn. So let's get started. We're going to talk about absolute value inequalities. So we've done absolute value equations, we've done inequalities. Now they're going to be absolute value inequalities. Okay, so you're going to have two different cases. You're going to have case one, case two. Case one is going to be greater than or equal to. That just means this is going to end up becoming either an and or an or based upon whether it's greater than or less than. I'm going to give you a way to try to remember them, or you're just going to have to memorize that greater just means or, less than means less than. Here's the way I choose to remember it. So if it's greater, I do it like this. I say greater, like that. That's how I remember it. I've done it since I was in high school, so it's helped me for years and years. So that just means that this is going to be a graph that goes opposite, okay? So when you're working it out, we'll get into some examples. You'll do all your calculations. They'll have an or in between it. You'll just break it up. It's a compound inequality. You break it up with an or in the middle, and then when you graph it, it'll eventually it'll end up looking like this. So it'll be from -7 to +7. So it'll go greater just means that they're going to go opposite ways when you graph them. It also means that it's going to have this same setup here that we've discussed, which is your negative infinity goes first, then your lowest number, which is -7. In this case, it gets a bracket. You got another bracket, greater number, which is 7. And then we got to account for infinity. So that's going to be our greater than or less than. So I choose to remember it with greater, like this, greater. Second case will be less than. Now, here's how I choose to remember it. I say less than. It's kind of weird, but that's how I choose to remember it. Greater, less than. That's how I remember it. Or you can just figure out that you can just memorize that they go with each other, that less than goes with and greater goes with or. I just always say greater, less than. That's how I remember it. So this is going to be an and, so you'll just break it up with an and in the middle, or you can make it condensed. It's your preference. I don't know if I'll condense any of them. We'll see. Then when you graph it, these, so when we say it's and, that means it's going to go towards each other like this. Okay, so we're going to start out at -4. We're going to have +4. They're going to be connected like that. So that's what the graph will look like. And then when we put it in interval notation, put our lowest number first, greater number second, figure out if we need brackets or parentheses. In this case, we need brackets. And that's all you got to do. So I put in some steps for solving these. So we'll just go through that real quick. You're going to want to isolate the value expression or the absolute value, similar to how we did before. You can use the KISS method, which just means you're going to create two separate classes. And when it says keep, switch, switch, that means you keep the inside. You're going to switch the inequality symbol. And you're also going to switch the sign of what it's equal to, or less than or equal to, or greater than, whatever. Okay. Then you're going to solve both inequalities. And then you're going to graph your solutions, write your answers, blah, blah, blah. Okay, so I'll give you an example of what that looks like here. So we're going to start off with number 1. Number 1 is the absolute value of x plus 6 greater than 7. So I see greater. I know that I'm going to have an or in the middle. Now, we take the inside. This is part of the KISS part. So it's keep, switch, switch. So keep the middle and keep the original equation without the absolute value. Then you're going to switch and switch. So keep the middle, switch the sign of the inequality, and then switch the sign of the number. So this is what it would look like, all worked out or all formatted out. Now, you're just going to solve each of these. So we got x plus 6 on the left. We're just going to subtract 6 by both sides because we want x by itself. So x greater than 7, or we'll do the same thing on this side, subtract 6 from both sides. So this whole part right here would be our answer to solving it. So we just solved it. Those would be the answers. It'd be x greater than 7 or x less than negative 11. So you need to write that down. Actually, it would not be 11. It would be 13. I don't know where I got 11 from. So it'd be 13. That's just negative 7 minus 6. All right. Now we're going to graph it. So make sure you write this down. I'm erasing it. All right. So our worked out answer was we had x greater than 1 or x less than negative 13. Now we need to graph that. So we're going to go to negative 13 first. So let's go down to negative 13. That'd be like right around here. It's going to be an open circle because there's no line under it for the less than or equal to. It's just less than. Since this is an or, we know that they're going to go opposite of each other already. Or you could just say x is less than negative 13. So I know I've got to go, my line has to point towards everything less than negative 13. Okay. And then we've got our 1 here. It's going to be an open circle. And we need everything greater than that. So since it's an or, we know they should be going opposite of each other. So we've got that. Now we just need to put it in interval notation. So you're going to start with the same setup every time. Negative infinity. So parentheses, negative infinity, comma, our lowest number. So that's going to be 1. It's going to have a parenthesis since it's open circle. We're going to do our union. Open parentheses. Because it's an open circle, we're going to have, actually, let me back up. I did this wrong. Making all kinds of mistakes. So we got to start with our lowest number, which our lowest number is negative 13. There we go. Now we got to start with, when we do the union in our next set, we have to start with the larger number, which is 1. And then we do infinity. So that's what it would look like with a few mistakes. So that's the basic setup. You're going to bring your middle out for both of them. For the first one, you're going to keep it. You're going to keep everything the same. So you'll keep this part. That's part of the kiss that you can remember it by. And then it's switch. So what switches is this part right here is going to switch. You're going to switch both of those signs. So you're going to make it, if it were greater than, it's going to become less than with a negative 7. So both of those will switch. Originally, we knew that it was an or because it was greater. So that means that when we graph it, our graphs are going to go opposite of each other. And that's it in interval notation. And is done the same exact way, except like on number 2. This is less than, or less than, you can say. So we know that's going to be an and.
The raffle tickets have been picked. Check your email to see if you win, and come see Bunny if you did. Have a good afternoon.
Okay. Sorry for that. So in number 2, this would be less than. So you would just have same process. 2v minus 3, you would keep this. And then you would just keep that the same. Then you would just switch it when you kept the middle of the second one. I'm not going to work it out because it's a pretty simple one. Okay. Now, that's where these ones at the start are going to be where it's isolated for you already, the absolute value is. Now we need to isolate them ourselves. So I'm going to do 2 hard ones, which is 7 and 8. Okay. If you struggle with the other ones, we'll have time to talk about it. So let's look at these real quick. If you'll notice, we have negative 10 outside of the absolute value. We have to isolate that absolute value. So we have to deal with that negative 10. And by doing that, we're going to have to divide because this negative 10 is just directly beside it, which means it's multiplied. So we've got to divide by negative 10 by both sides. Now, when we do that, the rule is this is the same for every inequality. If you divide or multiply by a negative, the sign flips, which means this inequality sign will flip. So now our new problem becomes 2r minus 1. It's the absolute value of that. Greater than, less than, negative 60 divided by negative 10 will make a 6. So that's our new problem. And we flipped our sign, and we also took care of this. Now that absolute value sign is isolated. That's what it means when it says absolute values have to be isolated. So that's by itself now. Then all you have to do is break them apart, work it out. Okay, I just wanted to give you that piece off the front end so you didn't forget it. Now let's look at, sometimes you're going to have this happen to you. So this is a harder one. Now if you'll look at number 8, these two are, they're both, you have to do 2 steps. You have to so you have to isolate this absolute value sign, but you have to do that 2 ways. So let me show you that. So you have this 9 here that does not need to be there, and you have the negative 5 there. So here's what you're going to want to do. You're going to want to move the negative 5 first. So we've got to get rid of this. So we're going to add 5 to both sides. Now, that's going to give us 9 absolute value 3 minus k. So we got rid of that. Sign stays the same because we didn't multiply or divide by a negative. 67 plus 5 is going to be 72, I believe. And then we're going to have to come back. This is the second part. So this is why this one's complicated. So this part is not finished yet. We have to isolate this inequality sign, or not inequality sign, absolute value sign. So in order to do that, we're going to have to go back again, divide by 9 on both sides. Now we'll have this isolated. So it'd be 3 minus k greater than 72 divided by 9 is 8. Now, that is isolated. So the absolute value sign is isolated. So you had to take those steps before you could even begin the problem to isolate the inequality sign or isolate the absolute value sign. Now we can go through and work this. Now you can pull it out, switch your inequality symbol, make sure this is negative, and solve it from there. And we'll do more examples of these, but that's just that's the basics. That's the basic way you do them all. So just to recap, make sure that you figure out if it's a greater than, less than. That tells you if it's or and. Remember, with ors, they're going to point opposite. Ands are going to go together when you graph them. You do these just like you would do absolute value problems. So you're going to just bring out the inside. The only difference is make sure to flip your inequality symbols. Other than that, we'll work more examples, but that is the end of the video.